Welcome to this webinar on careers and future in smart manufacturing. I'm Arun Pillai, the Director General at NAMTECH, the New Age Makers Institute of Technology, an educational initiative of ArcelorMittal Nippon Steel, and your host for this session. A little background about ArcelorMittal Nippon Steel. It's one of the world's leading companies, steel companies, a joint venture in India between ArcelorMittal and Nippon Steel, based in Hazira, Gujarat. And over the last 3 years, AMNS has invested roughly around 60,000 crores, around 6,000 crores, and with an intention to create jobs of around 70,000 jobs for the next 5 years. This initiative, ArcelorMittal, is an institutional initiative driven by CSR, and the focus is on scaling India's workforce for the manufacturing industry. Why this session and what is so important about something we are going to speak about? We all speak about India having a potential to be a global manufacturing hub. The government of India's policies, support they provide through the national manufacturing policy, linked to incentive schemes, the various mission projects like Make in India, Atmanirbhar, is to give a boost to manufacturing in this country. But world over, manufacturing sector is becoming more and more automated, more and more process driven. But in India, we see a lot of FDI inflow is happening in the manufacturing sectors. In fact, in the last 1 year, we have seen a big jump of close to 76% in terms of FDI investments. Last 21-22 figures speak of close to around $21.34 billion coming to manufacturing sector. But the challenge is, do we have the skilled manpower to address this opportunity? There is a critical need to align higher education and technical education to these smart manufacturing requirements. This panel whom we have put together is a distinguished one, and I have the pleasure of introducing to both the panelists. First, Dr. Krishnan, Dr. Krishnan Balasubramanian. Professor is currently the Institute Professor, Indian Institute of Technology, Madras. Serves as the head of the Center for Non-Destructive Evaluation, which he founded in 2001. He also directs the Gopal Krishna Deshpande Center for Innovation and Entrepreneurship. Close to 490 technical publications. He was the Dean of the Industrial Consultants in Sponsored Research at IIT Madras for close to 6 years. 2018, he was bestowed with the prestigious Abdul Kalam National Technology Innovation Fellowship. He's been a recipient of the DRDO Academy Excellence Award as well as the Lifetime Achievement Award at IIT Madras. My second co-panelist is Mr. Volker Schmid. He's the head of Asia Pacific for Festo Didactic SE, graduate engineer in mechatronics and automation engineering from Esslingen University, Germany. With postgraduate studies, he's lived across the globe in Singapore, Thailand, Asia, and then during the last 20 years, he's got a global perspective manufacturing from an industry side. He has been developing the educational market for Festo Didactic in this part of the world. He also has recently set up the Competence Center for Digitalization Technologies Innovation in Singapore. This is a joint initiative of Technical University of Munich, Asia, Festo Didactic, and the Singapore Economic Board. He writes a lot, he's a frequent writer, and has a number of publications to his credit. Thank you, gentlemen, for being part of this panel. I'm sure the participants would benefit immensely by insights in the world of smart manufacturing. Thank you very much. Let me begin with you, Dr. Krishnan. Smart manufacturing, Dr. Krishnan, has so many meanings, for many people. Some associated with the machinery getting connected to the internet. Some others say the information technology fusing with or merging with operational technology, industrial robots replacing manual process, cloud computing, large amount of data management. So many ways, people talk about smart manufacturing. In your own words, Doctor, could you just tell us what do we mean by smart manufacturing?
Hi, good evening. Thank you, Arun, and setting the stage up. And very good evening to all the participants. I see the participant list is exceeded 200 already. And I think this is an amazing event, and very happy to be a part of this. Just to answer the question, what do you mean by smart manufacturing? I think we are all smart here, but if you look at conventional manufacturing, you're talking in terms of very good old days. We used to talk in terms of what we call as a feed forward manufacturing. What I mean by that is, there is to be human manpower, there'll be machines, and then there'll be a formula of how to make this manufacturing work. And you make a manufacturing, whether it's a small, component for auto manufacturing, or whether it is manufacturing for textile industry, or whether you're mixing up some sort of concoction, and then that becomes either a petrol or gas, or whatever be the or even milk or dairy products. All of these manufacturing were done with a conventional approach where humans, machines, and a formula was used. Little later, probably after the 50s and 60s, people started realizing that there are other things that can benefit the manufacturing. So you started introducing sensors. Slowly, computers, microprocessors, all that started emerging in the 70s and the 80s. And then we realized that we need to do something beyond that. We need to start looking at what is called the feedback manufacturing, which is you take these measurements, you see how things are in a more automated way, and then you start to make corrections to the manufacturing while the manufacturing is going on. Now, in the last 15, 20 years, a lot of new technologies have emerged. Certain things that never was thought possible is possible today. The kind of processing speeds and capability that we have, the networks that we are able to manage, the sensors that can think and talk to each other, the artificial intelligence, of course, being the big thing over the last few years. Also looking at data and controlling the data using augmented reality, virtual reality. All of these are now coming together, where today we're not looking at individual machines. We are looking at the entire factory as one unit, where machines can talk to each other, machines work with each other thanks to the sensors and the networks. You have robots that are controlling the manufacturing instead of human muscle power. You have now robotic muscles that are actually doing the job. You have lots of sensors that are monitoring what is happening in the manufacturing. And you also have engineers that are not going to be anymore sitting on the shop floor, but sitting outside the shop floor in probably a nice air-conditioned room in front of their computers, and manage and do the engineering from there. So that is a big difference that you see in terms of smart manufacturing. So you are now going from a very small feed-forward scenario to a completely networked smart manufacturing scenario where information drives the manufacturing and drives the quality of manufacturing. I hope that answers it. Go ahead. Yeah.
Thanks, Dr. Krishnan. So, data driving manufacturing, feedback manufacturing. Volker, from your end, what do you mean by smart manufacturing?
Thank you very much, Arun. Can you hear me properly?
Yeah, we can.
Good. I first of all do not want to repeat what Professor Krishnan has mentioned. That's fully correct. In my point of view, or let's say in certain definitions, we may define different smart manufacturing or smart machines. The first phase would be starting with design of the machine, meaning new machines. That means we can use smart tools to design smart machines. So with the new engineering tools available, either provided by neutral providers or by the manufacturers itself, there are so many configuration tools. There are so many tools to, first of all, design a smart machine. Design of course, nowadays we also need to consider not only the machine itself, but how can it be integrated? How is the energy consumption of the machine? How does the communication protocols look like? And maybe in the near future, we even need to understand how do we recycle the machine. So that all maybe can be considered even as smart. And then the second phase would be the building of the machines. Here, Professor Krishnan has given all the ideas already, smart sensors, also more energy efficient machines, just also downgrading or let's say right sizing of the machine for the specific application. And then we have a phase which is the operational phase. Of course, here we have the connectivity. Here we have the data analytics. We have the continuous improvement of the machine. Here we can also talk about artificial intelligence, continuous improvement, self-improvement. And the last phase, as I already mentioned, could be even how professionally recycle such a machine. And of course, the operational phase, maybe even the last phase is also applicable to existing machines. That means how do we integrate standalone machines, existing standalone machines, by adding smart components. So this would be, in a nutshell, the overview. In addition, from our perspective, how we see the topic of smart manufacturing, respectively, smart machine.
Sure. Thanks, Volker. Now that there is a sense of what is smart manufacturing, from both an academician and from an industry professional, it makes sense to look at which industries, both globally or in India, most affected by smart manufacturing. So, Professor Krishnan, in your own experience over the last decade or maybe last 5 years, which are the industries where you have seen significant amount of impact, of the smart manufacturing techniques, tools, and technologies? It's not right. Professor Krishnan, you are not audible.
So smart manufacturing has been evolving over the last 25, 30 years. It's not something that suddenly we have come across. It's been around for a long time. In fact, I'll just give you a very nice example. So I was in Germany, and Volker is, I'm sure, not very far from where Volker was. This is one of the largest Mercedes plant that manufactures every car every 80 seconds or so. This was about 6, 7, 8 years ago. I forget where it is. This was in Bremen, in north side of Germany. And so they took me to one of the plants, which is the body plant. And I go inside, and there's a big board on the outside. It said 2,080 robots work here, and 8 humans also work there. And it is a very interesting experience because I have not seen robotics at that scale. And everything is done by robots. And then I asked them, why do you need humans? Because the robots are doing quite well. And these 8 humans are there only to intervene whenever something doesn't, suddenly once in a while things stops, and then these guys come and intervene. So robotics, a lot of smartness in manufacturing is nothing new. The auto industry is probably one of the amazing industries where they've adapted this very quickly, and that is because of the lot of competition. And today, if you go to more recent plants like what Tesla is, you'll see even more automation. Now, I've also seen automation, amazingly, in very more conventional industries. So I was working in about 2007-8 timeframe with the spinning mills and spinning mills in India. Okay. And in spinning mills in India, in 2006-7, the cotton is pushed inside these containers and in what they call bales. And very similar. Everything is automated. At the end, the thread, the nice cotton thread comes out in spindles. And so smart manufacturing is not something that has happened yesterday or today. It's been around for a while. It's getting smarter and smarter. The big difference between then and probably what is today and what's going to be tomorrow is going to be the use of information in a more sophisticated way. The use of artificial intelligence in a more sophisticated way. We're going to have a lot of flexibility today. In those days, these particular factories will manufacture a particular component or a particular product or a particular solution and do it repeatedly. And if you want to change that, then it will take a lot of time and effort to do that. Today's manufacturing and tomorrow's manufacturing is going to change that by having a lot of flexibility. So today I'll manufacture a particular vehicle, a car. Tomorrow I may change the design of the car, and within a few days I should be able to, or a few hours, I should be able to manufacture a different car, but using the same line. So you're going to have flexibility. So that is where the information processing helps. The flexibility in manufacturing. So the same robot can be reprogrammed within a very few short period of time to do something different. And this is where we are, and the time from design to manufacturing to deployment, that time will crash very significantly. A lot of artificial intelligence will be used. A lot of virtual reality tools will be used to make this manufacturing process, the transformation of the manufacturing process, more efficient and far more reactive. Now, there are many industries that are already adapting to that. In India, for instance, today, instead of making my own manufacturing, there's a small startup company, which is no more small, called ZWorks. If you go to ZWorks, the working environment is very different from a conventional factory, wherein, again, this flex manufacturing is something that's become the mantra, the DNA of that particular company. Many of the new companies that are coming up, Aether Energy is another good example of a company that's IIT Madras startup, where the environment of manufacturing is completely changing, where mind rules over muscle. And that's the big change that you're going to see as we transition in the manufacturing industry. Thank you.
So, Professor, you mentioned the auto industry, and you're also talking of several manufacturing startups which are using this kind of technologies to begin itself, right? That's the point you made right now.
Absolutely.
Volker, from your end, which are the industries you are seeing Festo products, automation, and smart smart manufacturing solutions being sought? Which industries are the ones seeking the most?
Well, I may not pick out a particular industry, all industries. When we look into the Indian subcontinent, I mean, Professor Krishnan has given a lot of examples. I mean, it can be the textile industry, it can be food and beverage, it can be automotive, you name it. The landscape of industries in India is so wide, we can just pick out one example and it may be already applicable. For me, important is now that companies understand this trend. Companies need to understand this trend and they need to start their digital journey. This part now, sooner or later, you will be gone from the market. We can look at Kodak, we can look at Nokia. Both are examples missing a trend, being market leader, but suddenly missing a trend and suddenly being gone from the market. And this is something that industries need to understand. If I don't start now, even if I'm the market leader, in 5 years' time, I may be completely gone from the market. So this is important. Important is to understand the digitalization journey. And it doesn't matter where to start, but it can also start on the top floor. But important is to start it, to define it, to implement it, And then also, of course, to define how do we train our existing workforce, how do we manage change management. And this is how companies will succeed in terms of competitiveness. I mean, earlier I mentioned smart manufacturing is also directly linked to competitiveness. I mean, we can produce faster, maybe cheaper, we can produce more reliable, we can produce higher quality. Professor Krishnan is more flexible. And the last part is what I mentioned as well. I mean, we can also produce cost saving in terms of energy saving. And this is something industries have to start now, and then they are and remain competitive in their own landscape. Thank you.
Okay, I think you can keep the microphone there because it's better that way. You're more audible in that fashion. When you keep it closer to your, it's better the other way. Okay. So that brings me to the third question. In light of all what we spoke, and the fact that smart manufacturing is something which is picking up, which is being rapidly adopted by Indian industry and industry globally. The question that rises is, what should be an engineer of tomorrow look like? What would be the profile of an engineer, considering the fact that so much technology change is happening in the industry? What do you think would be the profile of an engineer? How different it would be from what it is today? Professor, you want to go first?
What you are trying to say is, what should a future engineer look like? What should be a future engineer? Engineers, by definition, are people who make things work, who solve engineering problems, and provide solutions to those problems. Now, if you look at conventional engineers, the conventional engineering curriculum trained us, like when I went to college, it trained me to understand and using the knowledge that I have read to solve problems. So it is knowledge-driven problem solving. I think that is going to change. That's going to change a lot because knowledge today is available everywhere. The cell phone that you're carrying is far more powerful today than the entire library that I went to when I was in college. And the difficulty that you have to get into the library, find the textbook, find the right material, and then consume it, and then try to solve the problem. Today, that has changed dramatically. So the future engineer will be driven by experiential problem solving, will be driven by tool-based problem solving, where knowledge is embedded into these tools. So you as an engineer will have to learn how to use these tools more effectively and achieve a solution that is of value to the industry, to value to the manufacturing plant. And that is going to be the big difference. So you'll be far more tool-driven, but the knowledge is embedded into the tool. A very good example would be many years ago, when computers started coming, people thought so many of the people will be out of a job, but then many of them became software programmers. They upgraded themselves. They got more salary. Very similarly, if you can learn to do very well with tools that are provided to you, then the future engineer becomes far more valuable and far more creative. I think this is a great opportunity, and we are in exciting times where we're going to create future engineers that absolutely can do marvelous things. And that's already happening. Thank you.
Sure. Volker, you want to go on this? What do you think of future engineering look like?
Can go on, yes. And I don't want to repeat because that's all very valid what Professor Krishnan just mentioned. In also practical terms, we will see engineers also by means of education already who have a bit more practical knowledge, experience, and skills. What NAMTECH is also setting up, we can take NAMTECH as an example. This will be definitely an environment providing this skill development be theoretical based, but really practical based, and students will already have a chance to see the effects of changes on production like machines in the laboratory. So that will be a complete different skill set. When we go to the reality, Professor Krishnan has mentioned this already, we will have a lot of intelligent tools. I mean, also for Festo, maintenance for us is smartenance at the moment, developed by engineers. That means by means of digital tools, digital can also better perform certain tasks on the machinery, may it be repair, may it be improvement, and so on. And this is a skill set that future engineers will definitely gain by means of futuristic training programs, which are not only looking too much into the theoretical part of it, but also really develop the skill what is practically to be implemented. Let's call it like this. The question, what is practically possible in the industrial environment? Theoretically, everything is possible, but we need to also keep in mind that what is practically possible. Another big topic, I mentioned this 2-3 times already, of a future skill set of engineers is also environmental topics, sustainability topics. We talk about development goals, sustainability and development goals. So this plays a big role, not only in terms of environment, but also in terms of cost, because driving manufacturing costs. And last but not least, we need to have more agile engineers in terms of mindset, meaning future engineers need to be agile in terms of changes. I mean, when we go back in the Industrial Revolution, Industry 1.0 took maybe almost 100 years. Industry 2.0 took maybe another 50, 55 years, and so on. However, changes nowadays, skills to adopt change faster, even maybe less than just 2 or 3 years. And this is a skill set we also need to provide. How can a qualified engineer of the future be agile in adoption of these rapid changes already happening, and they will be happening faster in the near future.
Thanks, Volker. Just to add to that, and a simple way to look at it would be the engineer of the future would be someone with a T-shaped kind of knowledge set. While he has on the the leg of the T is the depth in the operating technologies, say in manufacturing. And we talk of the breadth in information technology required. So he has to marry both. He or she has to have a set of competencies related to information technology, fused with the knowledge and skill sets related to operating technology. And today's engineer probably have one of these two. Either they are IT engineers or they are, say, a mechanical engineer with the knowledge of operating technology. But in some cases, depth is missing. But tomorrow's engineer needs to be both, needs to match competencies. And that's when such an engineer could be relevant to a company from early days of joining a company. Yeah, so that's the profile we are talking of. If that's the kind of engineer we are talking of. Obviously, the next question that comes up is, do we have our engineering programs today which create such kind of engineers? We are saying that the smart manufacturing or smart technologies are significantly changing the landscape of manufacturing. We are saying the engineer of tomorrow is a completely different person from what today. But our engineering, Dr. Krishnan, you want to take that?
Okay, I'll try. See, today the things have not. The engineering education as a core worldwide has not changed much. If I go back to what I learned believe it or not, the same courses are still taught, and the same textbooks are still used in many cases. There has been a small change in the way we teach. Good old days is a good chalk and duster way of educating. Today, a lot of it is replaced with tools like PowerPoints. We have learned to actually create animations that will give a better perspective or a different way of learning. These are advancements that happened over the last probably 20-30 years, and this is true not only in India, it's true in many other countries, because I've taught both in US and in India. It's not changed dramatically. So then the question that comes up is this the right way to train future engineers? Now, one of the biggest difficulties I have, and I'll give you an example. I learned Fortran, and I'm saying this in spite, and I'm worried that people will guess my age when I say this, but when I learned Fortran, which is a language which many of you probably don't even remember, that's just like a C++ or any of the other languages, Python today. But Fortran used to be the one of the most scientific languages to learn way back. I learned Fortran, but I did not know why I'm learning Fortran. I had never seen a computer when I learned Fortran. Now, this is not only true for Fortran. Even an internal combustion engine, for instance, we go to the theory, we learn theory, why it works, what it does, what it does not do. And then maybe if you're lucky, you will go and be able to see an engine actually work in the lab. And it's assuming you do have a lab. If anything, the labs have actually decreased in numbers compared to what it was even 25, 30, 40 years ago. So I learn a lot of theory, but I have very little idea where the theory is being used. Now, what if we flip that? What if we flip that? We flip that by saying that let us learn how to do things first, and then learn why it works later. So some of us have been experimenting with these kinds of methodologies, where we believe that when you actually make something work or you see how things work, then you get more curious and you understand all the theory of how it works. So it's called flipping the learning. And I think this is one concept that is gaining a lot of traction. And I think this is going to make a big difference in how we create, future engineers. Another thing that's also going to be very important is how do you learn it? For instance, if I were to learn welding, I can learn welding by actually doing the welding. I can also learn welding. Today, there are enough tools available. And there's again a startup from IIT Madras called Skillvary, and there are many others in the world where you can actually learn welding without actually doing the welding, because they have a fantastic tool, virtual reality tool that allows you to learn it. And this is not just in welding, whether it's biological, curriculum. In fact, I was in Arizona State University not long ago, about a month ago, and one of the companies called Dreamscape, which is a big Hollywood company, has actually set up a fantastic center where they're developing hundreds and hundreds of virtual reality learning tools across disciplines. So I think that is going to make a big difference in the future. We also must change the way we look and evaluate students, because tomorrow's students are going to be judged. The future engineers are going to be judged by what they can do and not by what they know. So I'll give you an example. In one of my courses, I've been doing this for a while. This is called a design course, a design synthesis course. Two things I do. One thing I do is I do not go and teach on chalkboard. I probably give a small introduction to the topic, and then the students will be asked to read up and then come back, and then they will also share their concepts on what this concept is. They also have to pick a topic, a product that they will make it work. They will tell how it should work and what it should do somewhere during the course. And the evaluation is done in a half an hour. They're given half an hour at the end of the course. And if the thing works exactly as they had originally planned to do, then they get a high grade of A. If not, then they're given another chance a week later to make it again work, but then they will be shooting for a B grade. So it is more by evaluating the process of getting things done, which is exactly how you simulate a real environment that they will be subjected to in the industry. So it's more on presentation, product demonstration. I used to make them at the end say that, hey, I am either a customer or an investor in this idea. Tell me why I should be interested in your idea. Give me what's called a product pitch. So not only I think we need to change the way we do things. We need to look at flip learning. We also need to change the way we evaluate the students. And this is a huge motivational factor. And typically in this course, I used to have to turn down a lot of students who wanted to register because I had a limited capacity in these students. So my experience shows that if you change the way you teach, absolutely, there's fantastic response from the students. Thank you.
Thanks, Professor. Very, very, very lucidly put about the changes required in pedagogy, curriculum, etc. Moving on to Volker, I also see most importantly, a company like Festo has tied up with a university like Technical University of Munich to offer a program in Singapore, which is one of the few programs where I see industry and university coming together. Do you see these kind of programs being something which maybe today are quite few and far, but going into the future, a number of such partnerships coming in program offerings?
Well, thank you very much, Arun, for mentioning this. Well, our cooperation, what we do in Singapore and Asia Pacific, is just one example. There are others around the world, and I'm pretty sure we will do something similar. We are on the way to do something exactly similar also with NAMTECH. We can look also in some other examples around the world, US, South America. It doesn't actually matter. Important is, and this is related to your earlier question to Professor Krishnan. What we want to change is more moving away from the theoretical dominated part also that universities are still providing. I don't want to say they will do this for longer, because university teaching will also change tremendously in the next 5 to 10 years. I'm also pretty sure that universities will not only be able to continue with strict programs. They also need to offer much more flexible programs in order to cater the need, because the future job requirements means more flexibility. I don't need maybe 3 or 4 years or 5 years for a certain skill with a title. Industries need new skills within half a year, and education has to answer this need. And this is why these models are changing. And that's what we have started a couple of years back with TUM in Singapore. This is what we are starting also now with NAMTECH, to bring more industry. That means, what are the real needs? What are the upcoming needs in the next 1 or 2 years? And if we design programs accordingly, that means when students graduate, they would meet exactly the demands of the industry at the time of graduating. And this is something which is a big mismatch at the moment as well. Unfortunately, we see the industry normally a bit ahead of academia. And this gap is something we need to close. We need to make engineers in terms of meeting what the industry needs at the time of employment, and therefore reducing also the time of on-the-job training. Future graduates, new hirings must be able to immediately start within a very short time to be integrated into the processes, and even to be able to give more feedback to the companies in terms of improvements. And I mean, we can quote a very famous inventor. He also said, I mean, I don't want to hire people and tell them what to do. I want to hire people and they should tell me what I should do better, or what should I do something new. And that's exactly how it should be. And quickly coming back to the earlier question to Professor Krishnan, and this is something why also the mode of teaching has to change. Acquiring knowledge is happening nowadays by means of all kind of medias, digital learning, overnight learning nuggets, you learn when you need. So frankly speaking, we also need to support this new way of teaching. Teachers have to become more coaches instead of being a pure old-fashioned, sorry for using this wording, old-fashioned teachers. I mean, they have to become coaches, they have to be rather mentors, instead of remaining pure teachers as they used to be. And this is why we are also trying by this cooperation, may it be what we do in Singapore, but what we also do in Germany. I mean, for example, our head of research and development, 10% of his time he's investing in university. So Festo is giving our employees time to do teaching at the nearby universities. And this is how up-to-date problems are becoming part of the study program. That means students are confronted with up-to-date issues. They can, within the study program, within the course, try to help to solve such issues. And this is a much better qualification, leading to a much better, into a much shorter training on the job period, which is unfortunately still prevailing nowadays. Thank you.
Thanks, Volker. This trend about there being a single certificate at the end of the program and moving to something like a series of certifications, a single program having multiple certifications. Say an industry certification from, say, Festo, Siemens, interspersed with certifications from other agencies. So it becomes much richer. So that when finally a student lands for a job or when he faces an interview, he's able to say that here are the various certifications I've gone through during the course of my program. And that much more richer the program has become. It's a very good trend which we are seeing across the world. And this question finally to Dr. Krishnan. In light of all this, Dr. Krishnan, we spoke about smart manufacturing. We spoke about the industries getting affected. We spoke about the engineer of the future. We spoke about the programs. What does it mean for an education institution? How does a new age education institution look? How does the faculty look? I think Volker did allude to it, but from your, since you've been in quite a few number of decades in education, how does a new age institution look? If you could throw some light on it.
So I think there is a lot of realization by the education institution that they need to change. Some of the concept that just was mentioned by Volker is absolutely correct. We need to change the way we look at education. We need to change the way we need to look at educators themselves. As he just mentioned, educators need to become mentors rather than teachers themselves. So there's got to be, there are four basic concepts that I want to say here. First is educational institutions have to realize that they need to be extremely flexible in the way they teach and the way the students can learn. Today, more and more, you have to go experiential learning, but you don't have to necessarily mean that you need to bring a lot of equipment. Today, there are a lot of software available, a lot of, as I said already earlier, experiential reality tools available, which can actually change the learning experience, create a lot of flexibility, at the same time, give students a very different experience and which will become very useful to their, to their learning process itself. Now, one of the things that are really, probably the talk of the town in every university today is how do we evaluate? students. And the biggest problem that they have today is ChatGPT. So ChatGPT has created a paradigm and a paradox within universities, saying, how do we handle it? Now, the initial reaction was, let us ban it. But I think slowly everybody is realizing that banning doesn't get you anywhere. So how do we take into account that a student who has a ChatGPT window in front of him or her should still be able to be evaluated on what the person can actually do rather than what the person actually knows. So more and more the evaluation criteria will have to be based on what they can do. Another very important paradigm that is going to be very critical is today anyone can learn, anyone can teach. What I mean by that is today with online education, an example, for instance, IIT Madras, we were struggling to get about 9,000 students into our campus at a given point of time. We started an online program 2 years or so ago. Today, we have more than 20,000 students online, and still we have only 9,000 students in person. So online education is making a big difference. It's going to keep growing. This is not only true with us, it's true globally. And today, we are not only able to deliver coursework, but we're also able to deliver practicals online. And this is going to completely transform how you are able to even take package engineering programs and deliver it online and make it more and more experiential. Today, thanks to online, it is possible for anybody in any industry or any facet of life to come and become a teacher. I can be anywhere in the world. As long as I'm be a little flexible on my sleep time, I can teach students from here, students who are in the US or Europe, and vice versa. So I think tremendous change in the flexibility in terms of teaching or training, change in how you evaluate students, more on what they do or what they're capable of doing and not necessarily on what they know, and being able to deliver a cross-platform education by anybody, where the student can be in one end of the world and the teacher can be in another end of the world. All of that is something that every institute must address and take into account, because the world is changing at a dramatic pace and the educational platforms are changing even faster. Thank you.
Sure. That gives us, I think, 9 minutes left. So, Prof, I have some few questions. This question, Professor, if you could take, it says that whatever you say at the end of the day, the most paying industry is the IT industry. And do you see with the with smart manufacturing, this pay gap which exists between an IT engineer and a mechanical engineer, do you see it coming down?
So just to answer that, let me go back to my example of this Mercedes plant, where we went to the body shop. And then I asked, who is doing all the brain work here? I mean, you know that all the robots are being controlled. Everything is designed in a particular way. And then I was showed another building. And this building is no different from any IT building, where there are brilliant engineers who are actually coding the whole software that controls the entire factory and its manufacturing. So today, if you say a smart manufacturing job, I don't think there's too much of a difference between that and an IT job. If anything, it's even more realistic, it's even more challenging, it's even more exciting. And very importantly, we must understand that good old days, and this is true even today, if you come to any engineering institutions like IIT Madras, you'll see that we have very few women who take up mechanical engineering. But that is something that's going to change dramatically, because there's no difference between an IT job and a smart manufacturing job. So it's going to remove the gender bias. In fact, it's going to remove a lot of biases because the computer doesn't know who you are. Okay, it doesn't recognize you. It doesn't recognize the color of your skin, or it doesn't recognize the gender of you. So you're going to have a very different working environment where it is gender agnostic, it is bias agnostic. And that is going to be the big change that I see. And I'm seeing more and more, women come into this job. And pretty much, as I said, anybody can be a smart manufacturing engineer. And the salary structure probably is going to be more attractive than an IT engineer.
Sure. There's a question on, this is a much more question asking, since you mentioned tools, Professor, it's again directed at you. They are specifically asking that a new engineer should learn. When you spoke about tools, so I think this question is, what are the tools you're talking about? Would you like to take that?
You want me to take it, or you want Volker to take the question?
Since you mentioned tools, so therefore the person is asking you specifically.
See, the number of tools that are used by industry is many. But there are certain tools that will give you all the necessary skill set to be able to do something. All right. So if you want to take a smart manufacturing, there are some tools. For instance, one of the simplest tool is something to do with additive manufacturing or 3D printing, as it's called. So if you are able to program, design using an AutoCAD or whatever be the software, then you are able to go and be able to manufacture something through 3D printing, then be able to connect that component and assemble the component using, there are many tools. There are many tools that are available for 3D assembly, all right, which can be done virtually, and then you can actually physically do it. Then to be able to control the industrial robot or a cobot, to be able to pick and place. So these are some tools that if you know enough to get to a point where you can actually do things. All right. Similarly, there are tools that learn how to interface between an instrument and your computer, for instance, or interface an instrument to a machine and to a sensor. So these are tools that are not very difficult to learn. And as I said, once you learn that, you automatically get inquisitive as to, hey, how does it work? Now that I know how it works, I need to know how does it work. Okay. And that inquisitiveness will drive you better to learn things better. So it's not like I'm saying that you don't learn. You do learn. But you learn by first making sure you know how to make it work, and then you learn how it works, rather than the other way around.
I think we are reaching the end of our session. So just to wrap it up, first of all, thanks a lot for Professor and Volker for your insights.
Thank you.
Just summarizing the points you made. The first thing related to, of course, speaking about smart manufacturing, the range of technologies which are being used now to make Industry 4.0 manufacturing. We spoke about the in various industries, including auto. Spoke about the textile industry, where a lot of such kind of technologies are being used. Volker spoke about the various phases. One is, of course, the setting up phase, the operational phase, and also a continuous improvement phase where AI and other technologies are used in this manufacturing. Professor, you spoke about flipping the learning. You spoke about the use of VR learning tools. Most importantly, you spoke about the various changes in evaluation. So you spoke about how examination or a essay-based examination not being the only way, but we need to look at other models of evaluation. Volker spoke about the the need for learning sustainability in these programs. The use of sustainability becoming much more, the theme of sustainability becoming quite important. We also spoke about the kind of engineer of the future and the kind of programs in light of this. The need to be flexible, the need to have, and of course, the need to be the need of the kind of new age education institution that can offer such programs. I think it's been a valuable session, and you have been great panelists for me. You have patiently answered some of my questions and also those of the audience. So thank you very much. Thank you very much for joining this webinar. And thank you all of you who have been part of this webinar. Thanks a lot. Thank you.
Hope to see you one of these days. And thank you, Arun, Nandini, and the whole team.
I would want to make a quick suggestion. Let's try to make this again, but in real, face-to-face at NAMTECH in due time, okay?
Thank you.
Have a great day. Have a great day, everyone. All the participants have a great day. And good luck to all of you.
NAMTECH.